Hello dear students, I welcome you all for your first semester mathematics classes and I hope you all are safe and healthy. So in the last session what we have discussed, that is Leibniz theorem, and I have told you that is very important theorem for your examination. So under that we will take some examples. So in this session let us start with the examples where we are using Leibniz theorem to find the nth derivatives. In that first example I have taken is, that is find the nth derivative of x cube log x. So it is in the form of u into v. Yes, for here to get the nth derivative we will apply Leibniz theorem. Yes, take down now solution, that is first given function I will take it as y, that is given y is equal to x cube log x I will consider, and this is equal to u into v. So here we have to choose u and v. Yes, here I will write u is equal to log x and v is equal to x cube. So you may get a question like, why we have to take u as log x and v as x cube only? See, the v function we have to choose such a way that its derivative, that is after some derivatives we will get it as a 0. That is what? Its higher derivatives gets vanishes. See, for the v that is equal to x cube, if you are taking fourth derivative, its derivative value becomes 0. But that is not applicable for this log x. That is what? Its derivatives exist and it continues. So to get the answer easily, that is what one logic we have to apply. V whatever function we will consider, its derivative must get vanishes after some steps. So ಈಗ v ಅಂದ್ರೆ x cube ಎದಕ್ಕೆ ತಗೊಂಡೇನ್ರಿ, after third derivative whatever derivatives ನೀವು ತಗೋತಿರಲ್ಲ ಅವೆಲ್ಲ 0 ಆಗ್ತಾವೆ. So in such a way that we have to choose this function v. Okay. Now let us write by Leibniz theorem. So by the Leibniz theorem I will first write the formula, that is by Leibniz theorem we have u into v n, that is nth derivative of u into v is equal to nth derivative of u into v plus nc1 n minus 1th derivative of u and first derivative of v plus nc2 n minus 2th derivative of u and second derivative of v. So next I will write nc3 n minus 3 derivative of u and third derivative of v plus and so on, and what will be our last point, that is ncn is u as it is and nth derivative of v. So this is by the formula we have written. That is what? By the Leibniz theorem we have derived this in the last session. By using this we will now get the nth derivative of this function. Okay, see here u into v is nothing but, yes, now substitute the values, that is x cube log x and its nth derivative, that is equal to nth derivative of u means nth derivative of log x and x cube as it is, because v we have taken as x cube, then plus nc1 log x and its n minus 1th derivative first derivative of x cube plus next is nc2 n minus 2th derivative of log x and second derivative of x cube plus what will be the next term, that is nc3 log x and its n minus 3rd derivative and third derivative of x cube plus and so on, plus last term will be, that is ncn log x as it is and into nth derivative of x cube. Now what we have did, wherever u is there we have substituted log x and wherever v is there we have substituted x cube in this Leibniz theorem formula. Now see here, we know that nth derivative of log x, yes, that is what I will write, if y is equal to log ax plus b, this we have derived, that is nth derivative of log ax plus b is nothing but minus 1 raised to n minus 1 a raised to n minus 1 factorial divided by ax plus b raised to n. So while discussing the nth derivatives, I have already told you, you must remember nth derivative of each function whichever we have derived. Now by using this one, I will write here. So for this same formula we will get, just we have to take as a is equal to 1 and b is equal to 0. Next here n minus 1th derivative, whenever you are writing n minus 1th derivative, just substitute n equal to n minus 1 in this formula. Okay. Likewise we have to get the each term by using this formula. Okay. So I will write next is, that is x cube log x nth derivative is equal to, yes, log x nth derivative is minus 1 raised to n minus 1 a raised to n, that is 1 raised to n, and n minus 1 factorial divided by, see, ax plus b, that is what our only x is there. So I will take it as x raised to n. This is with respect to log x and its nth derivative. Now x cube as it is, plus next see here nc1 value, nc1 value, that is equal to n. See, already we have proved, because ncr value what we are writing, n factorial divided by n minus r factorial into r factorial. By this, if you have substituted r equal to 1, what we will get here, nc1 value as n. So directly I am writing this nc1, nc2 and all other terms. So you should get those values by using this NCR formula. So next, yes, nc1 value we have got it as n. Now n minus 1 derivative of log x, how we are getting? Substituting n equal to n minus 1. So substitute here and we will get minus 1 raised to n minus 1 minus 1, that I will write as n minus 2. Again a raised to n is 1 raised to n, and here n minus 1 means we can write it as n minus 2 factorial divided by x raised to, yes, x raised to n minus 1. So this is of log x and its n minus 1th derivative. Now what this means? First derivative of x cube. So what is the first derivative of x cube? That is 3x square plus, yes, that next term I will write here. nc2 value, that is by using formula we will get it as n into n minus 1 divided by 2. Now nc2 value is over, then n minus 2th derivative of log x we have to write, that I will write minus 1 raised to, again n minus 3, 1 raised to n. Yes, here we have to get it as n minus 1 and similarly here n minus 2, because we are substituting here n equal to n minus 2. So, and now next term is what? N equal to n minus 2, if you have substituted, that becomes again n minus 3 as we have written here. Then denominator is x raised to n minus 2. Yes, writing this term is important. Then into, next is what? Second derivative of x cube. See, already first derivative we have found. Then by using this, its second derivative means just one time we have to differentiate it. That becomes 6x plus, then again nc3 value I will write n into n minus 1 into n minus 2 divided by 3 factorial. Yes, 3 factorial. If you want, here also you can write it as 2 factorial. Now nc3 value is over, again n minus third derivative of log x, here substitute values, what we will get? Minus 1 raised to n minus 3 minus 1, that will be n minus 4, then 1 raised to n minus 3, and next is n minus 4 factorial divided by x raised to n minus 3 and into, yes, third derivative of x3 is what? It's again one time derivative we have to take, that is 6 plus. See, the next terms I will write it as 0. So you can write first all these terms by using formulae. Then what about the next term? That is contains, that is fourth derivative of x cube it contains. And what is the fourth derivative of x cube? That is either the differentiation tagobekri. What is the sixth differentiation? We will get it as 0. So the next term, that is this whole term we will get into 0, and I will write it as directly as 0. Yes, understood why we have taken 0? This is up to third, that is up to this. In the next term, what we will get? Fourth derivative of x cube, and third derivative we have got as 6. Fourth derivative andre enri? Third derivative na innom differentiate ಮಾಡಬೇಕು. ಈಗ 6 constant ada, its differentiation ಏನು ಬರ್ತದೆ ರೀ? 0. So 0 into this whole terms becomes 0, that I have written directly 0. Similarly, next all the terms we will get it as 0. Yes, so the next term vanishes. So this is why we have to choose v as x cube in this example. After this, I will adjust the terms. Yes, see here, that is equal to, that is x cube log x, it's the nth derivative. I will write as minus 1 raised to n minus 1, and 1 raised to 1 is 1, and I will take multiply and dividing by n. That is what? Multiplying, dividing by n, and rest all the terms I will write it as it is. And see, whatever this x cube is there, I will take into the denominator. So here it becomes as a x raised to minus 3. Yes, then plus, next is what? Minus 1 raised to n minus 2. Yes, again 1 raised to n minus 1 is there, that we will get it as again 1. Then n into, see, n minus 1 I will take here, that is multiplying and dividing by n minus 1, and into n minus 2 factorial divided by, yes, into 3 is there, divided by x raised to n minus 1 and into x square, and this n minus 1 I will write here. Okay, why we are multiplying this n and n minus 1? Yes, in the next step you will come to know. So, yes, continue that, that is minus 1 raised to n minus 3. Again minus 1 raised to n minus 3 is 1, that is, sorry, 1 raised to n minus 2 is again 1. Then here n into n minus 1 is already here. I will take that is with respect to n minus 3 factorial, and in this term I will multiply and divide by n minus 2. So the term becomes as, here 6 is there, so whole divided by n minus 2 we have taken, n minus 2. In the denominator it is x raised to n minus 2 and into, yes, that x raised to minus 1. Yes, here also it is minus 2 we will get, sorry for that. And then whatever is that, 2 factorial is there, that I will write here. Yes, 2 factorial is nothing but 2 itself. Then taking next term, what is that? Yes, every term is over, or what? N into n minus 1, minus 1 raised to n minus 3, then n minus 3 factorial, 6x, 2 factorial, and this term. Okay, that is over. Next term, minus 1 raised to n minus 4, minus 1 raised to n minus 4, and taking that n into n minus 1, n minus 2 with respect to n minus 4 factorial, and here I will multiply and divide by n minus 3, and we get n minus 4 factorial into 6 whole divided by, yes, what is that? 3 factorial is 6, I will write. Again x raised to n minus 3 into, yes, this n minus 3. Only this term we have left with. Yes, in this step what I have did, this n terms I have taken one sides, and in each term I have multiplied some term. That is, in first we have taken multiplying and dividing by n, here n minus 1, similarly n minus 2 and n minus 3. Why? Because in the next step we will get that. Now see here, this minus 1 raised to n minus 1, I will get it as it is. Then n into n minus 1 factorial is nothing but it is n factorial. So in the denominator what we will get? N into, see, x raised to n, x raised to minus 3, a raised to m into a raised to n, what we are writing? A raised to m plus n. So it becomes x raised to n minus 3. Then next plus minus 1 raised to n minus 2 and n into n minus 1 into n minus 2 factorial. Again this term is nothing but n factorial, and this 3 as it is divided by n minus 1 into, see, again x raised to n minus 1 minus 2 we will get, and that is what value? x raised to n minus 3 again. So coming to the next term, that is what? Minus 1 raised to n minus 3 again n into n minus 1, n minus 2, n minus 3 factorial. If you substitute, that is if you combine all these terms, again it becomes n factorial, and this 6 I will write as it is divided by 2 into n minus 1, 2 into n minus 2 is there, and into x raised to n minus 3 again. So plus minus 1 raised to n minus 4, again it will becomes n factorial, and into 6 divided by 6 into x raised to n minus 3, and that into n minus 3 I will write as it is. So here in this step 2 and this step, that is 2 3s are 6 get cancels, and here 6 and 6 get cancels. So check here, in every term I can take minus 1 raised to n minus 1 as common, even this n factorial and also x raised to n minus 3, that is common in every term. So let us take that to the outside. We get minus 1 raised to n minus 1 n factorial divided by x raised to n minus 3. Okay, in the bracket what we left? See, minus 1 raised to n minus 1, that is already taken outside. So remaining is 1 by n. Okay, next plus minus 1 raised to n minus 1 is taken outside. So here we left with minus 1 raised to minus 1 into 3 divided by n minus 1, and already this x raised to n minus 3 is outside. Then plus, similarly here we left with minus 1 raised to minus 2, because n minus 1 is taken outside. N minus 1 minus 2 means again n minus 3 we will get. So minus 1 raised to minus 2 is remaining, n factorial is taken outside, 3 is there, divided by n minus 2, and this x minus 3 is again outside. So similarly in the last term we will remain with is minus 1 raised to minus 3 divided by n minus 3. Now check here, minus 1 raised to minus 1. See, minus 1 raised to minus 1 is nothing but 1 divided by minus 1. Okay. Yavag negative power itadre denominator tagondre enagtadare? Yes, plus 1 becomes, that is plus 1, and 1 by minus 1 is nothing but again minus 1. Okay. Similarly here minus 1 raised to minus 2 is there. We can write it as 1 divided by minus 1 raised to square, and 1 divided by minus 1 whole square is plus 1, it is 1. So similarly minus 1 raised to minus 3 we will get it as minus 1, because minus 1 cube we will get in the denominator, and minus 1 cube is minus 1 itself. So writing those terms, we will get our final solution as minus 1 raised to n minus 1 n factorial divided by x raised to n minus 3, 1 divided by n, this is minus 3 divided by n minus 1 plus 3 divided by n minus 2, again minus 1 divided by n minus 3, and now this is our nth derivative of x cube log x. Yes, that is how we have found nth derivative of this given function by using Leibniz formula. Okay, yes, this is our final solution. So the second example I will consider is find the nth derivative of e raised to x log x. So this is our given function in the second example. So let us start with the solution. Again, given function is given e raised to x log x is equal to u into v I will consider. Now in this, which function you have to take as u and which function we have to take as v? Yes, I will take here, let u is equal to log x and v is equal to e raised to x. So in the previous example what I have told, ಯಾವ ಫಂಕ್ಷನ್ ನ ಡೆರಿವೇಟಿವ್ ತಗೊಂಡಾಗ ಆಫ್ಟರ್ ಸಮ್ ಸ್ಟೆಪ್ಸ್ ಅದರ ವ್ಯಾಲ್ಯೂ 0 ಬರ್ತದೆ, ಅದನ್ನು v ಅಂತ ತಗೋಬೇಕು. But e example ಒಳಗೆ ಏನದರಿ log x its derivative also continues, and here e raised to x derivatives also continues. So derivative of these two terms never ends. So anyone you can take as u and v. In both the way you can get the same answer. So here I will take u as log x and v as e raised to x. If you want to calculate, you can interchange. That is u as e raised to x you can take and v as log x. In both the way we will get the same answer. So let us proceed now again. Yes, this is important. You have to write in every example Leibniz formula you have to write. Okay. So by Leibniz theorem, we have yes, nth derivative of u into v is equal to nth derivative of u, v as it is, nc1 and n minus 1th derivative of u, first derivative of v, plus nc2, next is yes n minus 2th derivative of u and second derivative of v, plus nc3, n minus 3rd derivative of u and 3rd derivative of v, plus and so on. What will be the last term? That is ncn u as it is and nth derivative of v we will get. So by applying this, where u is log x and v is e raised to x, let us get the solution. That is nth derivative of log x into e raised to x. So I will write it as e raised to x into log x and its nth derivative. A substitute here. That will be nth derivative of log x and e raised to x as it is, plus nc1 n minus 1th derivative of log x and again first derivative of e raised to x, plus nc2 n minus 2th derivative of log x and e raised to x, that is second derivative of e raised to x, plus nc3 log of, that is n minus 3rd derivative of log x and 3rd derivative of e raised to x, plus and so on. Similarly, the last point is ncn log x as it is and nth derivative of e raised to x. So by using the formula, that is Leibniz formula, we have got this. Next, simplify this. So nth derivative of log x is there. I will write if y is equal to log ax plus b, that implies yn is equal to, yes, that is minus 1 raised to n minus 1 a raised to n minus 1th factorial divided by, yes, in the denominator what we will get, ax plus b raised to n. So wherever we are using the formula, you have to write. That is, everywhere you should give the reasons to get a good marks in exam. Okay. So by using this, I will explain. See why I have not given this e raised to ax plus b formula, because see e raised to x first derivative is e raised to x. So second derivative also e raised to x. Andre enri e raised to x na ನೀವು ಎಷ್ಟೇ ಸಲ ಡಿಫರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದ್ರು e raised to x ಬರ್ತದರಿ. So that I will write that one directly. Okay. Now let's write down the terms. What we will get? Log x nth derivative, that is minus 1 raised to n minus 1. Again a raised to n is there. A value is 1. So I will not write that term. Into n minus 1 factorial divided by x raised to n, that is ax plus b value is only we have x, into e raised to x as it is, plus ncn value is n and n minus 1th derivative of log x, means here we have to substitute n equal to n minus 1, we get minus 1 raised to n minus 2, again a raised to n value becomes 1, that is 1 raised to n minus 1 we will get, that is 1. I will not write that. Then here n minus 2 factorial divided by x raised to n minus 1. So directly I am writing now. Then yes, first derivative of e raised to x is e raised to x itself. So similarly nc2 value is n into n minus 1 divided by 2 factorial and n minus 2th derivative of log x. By this we are getting it as minus 1 raised to n minus 3 into n minus 3 factorial divided by x raised to n minus 2, and this second derivative of e raised to x, we will get it as e raised to x itself. Then next term is nc3. Its value is n into n minus 1 into n minus 2 divided by 3 factorial and log x n minus third derivative. Thus by this minus 1 raised to n minus 4 factorial divided by x raised to n minus 3. Yes, this is now over. Then third derivative of e raised to x, again its derivative we have to do, so that is again e raised to x itself, plus and so on. And NCN value, while proving the Leibniz theorem, I have told you this NCN value we will get it as 1 itself into log x as it is, and e raised to x, nth derivative is e raised to x. So as the function is e raised to x, I am writing here directly. Otherwise you can use the nth derivative of e raised to ax plus b also. By that also we will get the same term. Okay. Yes, next step is what? Simplifying the terms. So here I will write that implies nth derivative of e raised to x into log x is equal to, yes, write down this, that is again I will multiply and divide by the n for the first term, that becomes minus 1 raised to n minus 1 n into n minus 1 factorial e raised to x divided by x raised to n plus, so minus 1 raised to n minus 2 n into n minus 1 into n minus 2 factorial divided by, yes, as I have multiplied n minus 1, I have to take divided by n minus 1 also, and here x raised to n minus 1 into again e raised to x. This is second term. Similarly, I will adjust the terms in third, fourth and so on. So what we will get here? Minus 1 raised to n minus 3 n into n minus 1 n minus 2 into n minus 3 factorial into e raised to x divided by, yes, here we will get n minus 2 and x raised to n minus 2. So see here x raised to n minus 1 is there, so we have to multiply and divide it by n minus 1. Like this also you can remember. Here also x raised to n minus 2 is there, so I am multiplied and divided by n minus 2. Yes, so plus next term is minus 1 raised to n minus 4 n into n minus 1 into n minus 2 n minus 3. Yes, next is n minus 4 factorial e raised to x divided by, yes, in the denominator what we have? X raised to n minus 3, so I have multiplied and divided by n minus 3 plus and so on, it continues, and our last point is log x into e raised to x. So this is the terms I have adjusted. Then next, yes, simplifying these terms, what we will get? Yes, e raised to x, nth derivative of log x is equal to minus 1 raised to n minus 1, and n into n minus 1 factorial becomes n factorial into e raised to x divided by x raised to n. Yes, here we are multiplied and divided by n, so you should get here n into x raised to n I will write. Then plus minus 1 raised to n minus 2, this is n factorial e raised to x divided by n minus 1 into x raised to n minus 1. So next term is minus 1 raised to n minus 3 n factorial e raised to x divided by n minus 2 into x raised to n minus 2 plus and so on, plus and so on. Yes, if you want you can write this. Yes, already we have written that third. Then next term is what? Minus 1 raised to n minus 4, again n factorial e raised to x divided by n minus 3 into x raised to n minus 3 plus and so on, plus last term is log x into e raised to x. So see here, in each term e raised to x is common, and even this n factorial. So I will take that term outside. What we will get? E raised to x log x, nth derivative of it, that becomes, yes, n factorial into e raised to x I will take outside. Remaining terms is minus 1 raised to n minus 1 divided by n into x raised to n plus minus 1 raised to n minus 2 n factorial e raised to x taken outside. Remaining term is n minus 1 into x raised to n minus 1 in the denominator plus next term becomes minus 1 raised to n minus 3 divided by n minus 2 into x raised to n minus 2 plus minus 1 raised to n minus 4 divided by n minus 3 into x raised to n minus 3. This term is over, plus and so on, plus. Here n factorial is not there, but I have taken n factorial outside. So what I will write? Log x divided by n factorial, and this e raised to x is taken outside. So now this is the final solution. That is what? Nth derivative of e raised to x into log x is this term. Yes, this is how to get the nth derivative of functions given by using Leibniz formula. So here I will conclude this video, and in the next session what I will take, that is again 2 more examples I will consider under this Leibniz theorem. Okay, thank you.